So good day, I am Princess Everelle di Banaag, and for today's video, I will be talking about the different metal defects. So in conning industry, knowledge of different metal defects is essential for maintaining food safety standards. Identifying defects like pinholes or dents also helps us prevent contamination and ensures the integrity of the cans, safeguarding the quality and freshness of the packaged products. So in this video, I will be discussing some of the metal defects, its common causes, and the severity classification of the said defects. So to start with the metal plate manufacturing defects, we have here a pinhole. It is a hole in the metal plate originating in the rolling mill, and this will vary in size from barely visible to large irregular shaped holes with rough edges. So the common sources of pinhole includes foreign particles that may be rolled into the plate during rolling operation in the mill, which they do not bond with the plate. Also, the large particles will extend to both surfaces of the plate. When the plate is worked during can manufacture or flex during retorting, these particles may pop out, leaving a hole, or what we call pinhole in the plate. So a pinhole is considered as a serious metal plate defect. So next is the coating application defect. Another example here is a coater drip. A coater drip is a drop of coating, exterior or interior, often appearing as tiny hard metallic bubbles of coating. A coating drip may resemble a scrap-in-dye type defect. So, its sources is drips or splashes from the coating operation. And a coater drip is considered a minor defect unless careful examination proves that the defect is a serious defect. A coater drip is considered a serious coating application defect if a hole or a plate corrosion is detected after a thorough examination, which would include opening the can or removal of the coater drip to determine the condition of the metal plate. So we have here the can body manufacturing defects, the excessive solder. Excessive solder at the customer lap area of the side seam, which may cause the formation of a double seam at the crossover, resulting in excessive side seam droop, a raised seam, or a jumped seam. Excessive solder may also cause a pleat to form in the side seam lap. A thick lap is a condition where the side seam contains excess solder between the laps. This happens because of the improper wiping of the solder. And also, excessive solder is considered as a serious three-piece can defect. So another one is the can end manufacturing defects. I have here the double end. Two ends are seamed into one end of a can body. The double seam has the appearance of additional thickness and length and may have numerous droops or V's along the double seam. This happens when two stripes of end plate are stuck together as they enter the end press. The resulting ends have two thickness of plate that are curled together, and only the inner end is compound lined. Two independently formed ends are stuck together and double seamed into a body. A double end is considered as a serious container defect. So another one is a double seam defects, which is the false seam. It is a defect where a portion of the body flange is bent back against the body without being engaged with the end hook, but does not protrude below the bottom of the end hook radius. This is similar to a knockdown flange defect where the body flange is visible below the end hook radius. This defect is difficult to observe and requires close visual inspection of the underside of the double seam, where sometimes two layers of metal can be seen. Confirmation of this classification often requires a seam cut to observe the configuration of the end curl of the body flange. One common source of this is a flange damage during shipping, depalletizing, filling the can from the feed screw, the clincher, the seamer, or from product or foreign material on the flange. A false seam is considered as a serious seam defect due to the absence of overlap. So other manufacturing defects include misembossing. Misembossing includes sharp, illegible, misplaced, or multiple embossing. Sharp embossing may fracture the coating, leading to corrosion and perforation, or it may fracture the metal plate. Misplaced embossing, which interferes with the pull tab or is in or the score line or reinforcement lines or rings, is likely to cause a fracture in the metal plate. The common sources for this is that it can end going through the embosser twice, excessive embossing pressure, mismatch and embossing dies, and misfeed of can into embosser. Misembossing is considered a serious can end defect if the metal shows signs of fracture at the point of embossing or any part of the embossing has struck a sensitive area such as an easy open pull ring or score line. And last but not the least, the handling defects. I have here abrasion. Abrasion is a mechanical wearing of the metal plate, and abrasion results in the weakening of the metal plate, making the abraded area susceptible to either fracture or corrosion, which could eventually perforate the metal plate. The common sources for this is the action of moving cable or metal conveyors on stationary cans. This may occur with either empty or filled cans, and cans being moved against stationary objects with sharp parts. For example, loading cans into damaged or rusted retort baskets. Abrasion is considered as a serious container defect when the metal has been reduced to less than 50% of its normal thickness. So that ends this presentation. Thank you for listening.